Today's real numbers video will be relatively simple because we only have two rules to remember. And the good news for us is that both of these rules apply to multiplication and division. So our first rule states that if the signs are the same, the answer will be positive. So if we have two positives or two negatives in our problem, no matter what, the answer is going to be positive when we're multiplying and dividing. So you see we have a positive times a positive equals a positive. Even a negative divided by a negative, that is still going to be positive. But if the signs are different, then that means that their answers are going to be negative. So negative 40 divided by 5 is going to be negative 8. 3 times negative 7 is a negative 21. So these rules are not like our adding and subtracting rules where we're looking at the larger number and taking its sign. We're going to assign which sign our answer should be based off of whether we have two positives, two negatives, or different, one positive and one negative. Let's take a look at our first three, and let's try and remember these rules here as we do them. We are simplifying, so we're still carrying out the math operations as we always have. So we have a negative 9 times a negative 4. 9 times 4 is 36. But as far as the rules go, I have the same signs because they're both negative. That means our answer is going to be positive 36. Down here when we have 33 divided by negative 11, 33 divided by 11 is 3, but because their signs are different, 3 is going to be negative for the answer. These rules apply to all real numbers, and that includes fractions. So let's take a look at a fraction problem. Let's solve this multiplication with fractions using cross-canceling. 3's will cancel with each other. 2 and 4 are both divisible by 2, so 2 divided by 2 is 1, 4 divided by 2 is 2. And then we're multiplying straight across. So our numerator will be 1, and our denominator will be 2. And since our original fractions were both negative to begin with, that is our first rule here. Signs are the same. So my fraction will be a positive 1/2. I want you to try one. Use your negative and positive rules and solve this problem. We have negative 35 over 3 is our answer. And we can solve this by looking at our 5. If you are comfortable with putting a 1 under it, you can. There's nothing to cross-cancel in this example, so we're multiplying straight across here. And because we have a positive times a negative, our answer is negative. Let's talk about using these rules when we're evaluating expressions. When you are evaluating, it's very important to remember that you're supposed to be using parentheses in place of your variables. So writing the original expression down, I'm going to replace x and z with two sets of parentheses. And then I'll be plugging in my new numbers. So I'm using negative 2 for x and negative 6 for z. Now if I did not use those parentheses, I might think that this says negative 2 minus 2 minus 6. But these parentheses here in place tell me that I'm doing multiplication. And when you're doing multiplication in the order of operations, you're going from left to right. So negative 2 times negative 2 is positive 4 because they're the same sign. Then we have positive 4 times negative 6 from bringing this one down. 4 times negative 6 will be negative 24. The signs are different, and so our answer is negative. Let's look at a more complex evaluation problem. This time we're going to be evaluating x over y when x is negative 3/4 and y is negative 5/2. So again, we're going to be replacing our variables with parentheses. So for x, we're going to write negative 3/4. For y, we are writing negative 5 over 2. Now this is what we call a complex fraction, when a fraction has another fraction inside of it. So we have a bunch of craziness happening here, and this might be a little bit difficult to solve unless we remember that fractions are really just another way to write a quotient. And a quotient is just something that you're dividing with. So instead of thinking of this as a humongous monster fraction, we're going to say to ourselves negative 3/4 divided by negative 5/2. And if we rewrite it in a way we're used to seeing it, it'll be a lot easier to work with. So I'm going to write negative 3/4, and I'm going to use the elementary school division sign. And then I'll write negative 5/2. This should look more familiar to you because we can use a method called keep, change, flip to solve it. So what that means is that we are keeping our first fraction the same. It'll remain negative 3/4. We're going to be changing division to multiplication, and our second fraction gets flipped upside down. Notice that I kept the same signs for both fractions. It's very important to take your signs along with you every step of the way. Okay, as far as multiplying these together, I would like for you to finish it, and then we'll check our answers. After cross-canceling and multiplying straight across, I got 3/10, and because I have a negative times a negative, my answer is positive 3/10. We have one more thing to discuss today, and that involves exponents. When you are evaluating exponent, it is really, really important to remember that exponents only apply to the term to which they are attached. So what I mean by that is, if we look at this first example, this 4 is connected to the 3. It is only attached to the 3. This negative is kind of sticking out here in the middle of nowhere. It has nothing to do with its exponent right now. So when I start evaluating it, in my mind, I'm going to keep it off to the side. And when I do 3 to the 4th power, my brain is going to be thinking about 3 times 3 times 3 times 3. And I'm not going to be concerned about that negative just yet. Alright, so 3 times 3 times 3 times 3, that is 81. Now because I have a negative on the outside, I can now apply it. And having a negative on the outside is really like having a negative 1 on the outside. So those are interchangeable. This and this mean the same thing. And negative 1 times 81 is equal to negative 81. In our second example, it's a little bit different because this time our 4 is not attached to the 3, it's attached to the parentheses that contain the 3. And I want you to notice something else that's in those parentheses. Our negative has snuck inside, so this time the 4 is going to apply to everything inside that set of parentheses. So when our brain starts working to solve this problem, it's got to be thinking negative 3 times negative 3 times negative 3 times negative 3. If we are evaluating this according to order of operations, we're going from left to right. So negative 3 times negative 3, that's going to give me a positive 9. Positive 9 times negative 3 is a negative 27. Negative 27 times negative 3, that is going to be a positive 81. So you can see where the negative is placed in the beginning of the problem has an effect on what your answer will be, whether it will be negative or positive. So it's very important to keep track of all of those. A good example is this last one that we have here. I have negative, and then parentheses, negative 3 raised to the 4th power. What is the 4 attached to? It's attached to the parentheses. So that means that this 4 applies to everything inside this negative 3. What the 4 does not apply to is the negative outside the parentheses. So our brain is going to leave that negative alone that's on the outside, and on the inside we're thinking negative 3 times negative 3 times negative 3 times negative 3. And again, when you evaluate or using order of operations, you're doing what's inside the parentheses first. And we've just done this one. An example just like it. So what we have inside the parentheses here is 81. And we still have the negative that's on the outside. And remember, in our first example problem, we said that negative with parentheses is the same thing as having a negative 1 on the outside. So when you multiply those together, negative 1 times 81, that's going to give us a negative 81 for our answer. That will conclude today's video, and we will see you guys in class.